On this worksheet, we're going to practice drawing the product of the reaction between an amine and hydrochloric acid, HCl. As a reminder, an amine is a molecule that has a nitrogen atom with 3 bonds to different things. I'm just going to use question marks there because it could be a hydrogen, carbons, whatever. When the amine is reacted with hydrochloric acid, HCl, the hydrogen from the hydrochloric acid is added to the nitrogen of the amine, just like that. And the chlorine from the hydrochloric acid is just left all by itself as a chloride ion. Also, another thing that happens is that the nitrogen of the amine ends up getting a positive charge, so it becomes a cation. In organic chemistry, we like to circle our charges on ions just to make it easier for us to actually see the charges in the structures. Before we actually get started on these, I do want to point out that we are not doing this reaction on amides. The amide is a nitrogen that is directly bonded to a carbon-oxygen double bond. So anytime we see an amide, we're just going to skip over it. Also, in this reaction, every single amine in the molecule is going to be reacted with hydrochloric acid. So sometimes we'll be doing the reaction multiple times on the same molecule. So here's our first molecule. There are 2 nitrogens. This first one is an amide because it's directly adjacent to a carbon-oxygen double bond. So this is the only actual amine part of the molecule, and what we're going to do is just modify it. We're going to give it a hydrogen atom, we're going to give it a positive charge, and then we're just going to draw that chloride ion just somewhere nearby, just like that. Now let's take a look at lidocaine. Lidocaine has an amide, so we're not going to pay attention to that part of it. We're just going to focus on the amine, give that nitrogen a hydrogen, and also give it a positive charge, and then stick your chloride somewhere around. In terms of where you choose to draw the hydrogen, it doesn't matter. You could draw it anywhere you wanted. It doesn't make a difference. Where the positive charge goes, put it wherever you want. Chlorine, put it wherever you want. Xanax, we have 3 amine groups in Xanax. That means we're going to put a hydrogen on every single one of them. And we're going to put a positive charge on every one of those nitrogen atoms. And then also, we want to have a chloride ion to go along with every one of them also. So we're just going to draw chlorides all over in here. For Advan, down here, we've got an amide, so we're going to ignore that one. Here is our amine. Give it a hydrogen, give it a positive charge, put a chlorine somewhere around. Cocaine, put a hydrogen on that, positive charge, put a chlorine nearby. For clonopin, I left an I out over there, clonazepam. This is an amide, so we won't do anything with that one. This is something completely different. That's called a nitro. Here is our amine. Give it a hydrogen, positive charge, chloride ion. And we've got a couple of more to go. Morphine has 1 amine. Novocaine has 2 amines, so we'll put a hydrogen on that one, put a hydrogen on this one, and a couple of chloride ions. And then last but not least, oxycodone has 1 amine. Give it a chloride.